Good afternoon, everybody. My name is Sam Vines, and today we'll be talking about radios, how they work, and how they relate to UAS. And more specifically, I'm doing a technical demonstration about how they work in this little garage door opener I have. I'm in my car just so you can see the effects of the garage door opening or opener opening the garage door. Um, so to get started, obviously radios are all around us, from walkie-talkies to plain old like the radio in your car, to your iPhone, to cell tower, any just about every electrical application uh, uses radios, and therefore they are extremely important in everyday society. A lot of study has gone into them. There's a lot of technicalities and complexities that go into it, from interference to reception to amplitude. Um, just a lot of, uh, I guess, components of a radio frequency have to be considered. So to get started, we have our little garage door opener. I've already taken it apart. You can see this is the top part. This is the push button, obviously. Um, so right here we have the switch right there. So whenever I press this button, it in turn presses that switch, and then that's it. When that switch is pressed, it sends a signal to this unit right here, which is full of transistors, and those transistors right there decipher the signal and send signals to the um, surface acoustic wave filter right there. It's that little component right there. It says SAW1. What that does is that filters any unwanted frequencies. So for example, you wouldn't want multiple frequencies getting sent out because it would interfere with the reception from the opener itself, the main unit that is on top of the garage. Well, you can't see it. There we go. That thing right there. So what it does is it sends the proper signal there, uninterfered with, so it has a cleaner transmission to the unit. And then once obviously the unit receives the signal, that garage door will open for me. Pardon the filth on my windshield. A bird got me today. So obviously it's battery operated. It cannot operate without a battery. There's a watch battery for you right there. And this circuit board has a lot of different components to it. Obviously it gets the diode. It's got the different switches right there. It's got the transistors, small transistors. It's got the transistors pack. It's got different resistors on it. But anyway, and with the circuit, the radio here, since it is a radio, it has an FCC identification, and it will send a very specific frequency to the garage door opener. And what's interesting about that is that it has its own special band, which kind of acts as a password. And so when that password is detected by the motor, that's when it opens the door. So if we can see it, I wonder if the switch will open without the button attached. Sure enough. Go ahead and stop it so we can close it. So I'll let all the hot air out. So yeah, and as you can imagine, this concept, that though simple in this garage door opener, is very pertinent to drones, and as I mentioned, a million other applications. In drones specifically, this same technology is used to transmit signals from the remote, the remote control, to the drone itself. And those signals um, will dictate anything from drone movement, like climbing, moving forward, side to side. It could determine what the payload does. So if it's a camera, It will determine the tilt. It will determine the angle of the camera. Any kind of operation or appliance or payload on that drone, radio frequencies will be used to control the payload itself. I will include a video that explains really nicely the garage door opener itself aspect of the radio. So that was my garage door opener falling in between the seats. Thankfully, it already did the explanation. I will have to fish for that here in a bit. But yeah, so you can see how easily on a drone, how important that might be. But yeah, that's pretty much all I got. Not a lot of explanation needed for that garage door opener. Thank you for watching.